These are the front wheel bearings out of my recently acquired Morini 175 GT, and one side felt okay, although the grease that's in there is like treacle. I can barely turn that with finger pressure. The other side I could quite obviously see there didn't appear to be any grease in the bearing, and the whole assembly felt pretty rough. So you know, bearings are cheap, so it all came apart, and I've got new sealed bearings to go in. The original arrangement was just a felt seal, and it would just been packed with grease, but you know, putting a sealed bearing in is a much more sensible approach these days. These appear to actually have been sealed bearings, and someone's prized the seals out of them. It's possible that they were, I think these were Austrian bearings, certainly one's marked Austria. It may be that the factory was just doing the same cage for sealed and unsealed versions, or indeed shielded. So they've got the groove. But certainly I've experienced places that just stock sealed or shielded bearings and then pull them out if they're not needed. The difference in cost not being very much, particularly if you're buying in bulk. Anyway, with the bearings knocked out and the horrible congealed grease cleaned off the bearing spacer, well, you can see there's a huge, great big burr there. Let me bring it up. And the reason for that is the spacer is recessed at both ends, and it appears to have been made to fit over the inner race, to centralise the spacer. Now I don't know if that's original. It's possible it is. What I found on the later bikes is they actually have a pressed steel flange on this spacer, which roughly centres it in the hub, so that you don't end up with the spacer dropping down to the bottom of the bearing housing and then being way off centre, meaning you can't get the wheel spindle through without inserting a screwdriver from the other end and jiggling it up. Like I say, the later hubs, they've got a triangular sort of shaped inner housing that gives you access to the edges of the bearing flange more easily for knocking them out, and then they've got a little bit of a collar on the spacer which just stops it dropping very much inside the housing. So I may well do something similar. I might actually have an O-ring that will clear the housing but also roughly centre this so that you don't have to juggle too much getting the front wheel spindle through. Anyway, I need to measure the distance between the two bearing flanges in the wheel hub. So I'll go over to the other camera. I've got the wheel on the floor and I'll show you how I'll measure that. Okay, so I've got the wheel here standing in a wheel chock, and I'll just mention the wheel chock first briefly. These are fairly common these days as a very convenient way to either have it bolted to a base and just be able to wheel a motorcycle in and let go, which is great if it's for instance a race machine with no stands on it, or it's a machine with only a side stand, so it has to lean over, unless you've got something like this. Or this can be bolted to my my trailer to make loading much easier, because you can essentially wheel the bike in and let go, and then proceed to strap it down. It just happens to be a convenient way to hold this wheel upright. And we need to measure the distance between the two bearing seats, and a while back, and I think I probably showed these on video, but I bought myself some measuring tools, and this is a 50 to 75 millimeter Mitutoyo groove micrometer, and if I bring you up, and we're probably blowing the camera out, the light's coming, but you've got two discs here, and it will measure between the discs or over the discs, and there's two scales on the micrometer barrel, and I believe these were actually I can't remember, a couple of them were new in their packaging, and one of them had been used like about once, but they came from Russia of all places. But I can come in and feel for the point and get the measurement between the two flanges in there, which you know, you can get a hub micrometer would do a similar job, but this would also allow you to, for instance, measure the position of a groove in comparison to a face, so they can be a little more versatile. Not something that you necessarily want to go and spend a lot of money on, but you know, I saw these for the right price, so I just put them into the general tool stock, and lo and behold, suddenly I have an application where it's just ideal for the job. So I'm getting, because these are one of those instruments that read backwards, so I'm getting 64.5 millimeters or close to. The bearing spacer wants to be slightly longer than the distance between the two bearing seats, so that all the bearing preload, when the spindle's done up, is taken between the inner races, and the bearings in theory are then slightly loose in the hub, but of course they're a press fit, or in fact, because these bearing housings are a little bit worn on, you know, a 60-odd-year-old bike, they're not as tight as they could be, and I'll end up using a little bit of Loctite bearing fit. You know, they're not rattling loose or anything, but you can virtually push them in and pull them out by hand. So we'll machine up a new spacer and get this hub reassembled and put back on the bike, so that the bike's mobile again, because I need to get it out the way and get my my Sport onto the bench and its rear brake rebuilt. Okay, I'm just going to make this wheel bearing spacer. So I've got the bit of, I think this is leaded mild steel, but that's the free turning. So I'm just going to give it a quick polish up to clean this surface up, then part it off roughly to length. We'll drill it through, and then I'll finish it to length. So I've just lined up by feel. That's better. And we need under 65 millimeters, so I'm just going to go over about 66. Going to millimeter mode would be handy. Go. Make sure we're running backwards, and we'll come down in speed a little. Okay, now we're close to the centre, I'll bump the speed up. Just take that pip off because we're going to be wanting to put a hole in the end. Find ourselves a suitable drill bit. I think I should have a blacksmith's drill the right size. It turns out I don't have a 15mm drill available or anything too close, so I'm going to bore this out, but it's not particularly critical. It needs to be 15 plus clearance. So we'll start off by taking a skim cut and get a measurement. Bump up to high speed. Touch off and take a pass through. What I should have done really was get a Z off the end. No, how deep I'm going. Okay, I think we can call this a finish pass. It'll do the job. That looks good. I'll actually try the spindle through there, and that's perfect. just a little bit of clearance. So now I will take a length measurement, and then I'll touch off on the end and take it down to length. So I can take a length measurement, .16 we'll call it. So if I now come up and touch, and I put 66.1, so 64.75 will do us, and we've got 66.15 at the moment. I'll just flip it round and for the inside on the other end, and we're done.